Good morning. So today we have to talk about variances and standard deviations. Now you know how to compare averages or means with single number, or how to compare two means. For example, you know how to find out whether mean income of entrepreneurs is larger than that of paid workers, or is it true that average income of school teachers is no less than the average income in the region? Well, uh, but what if you want to compare variances? What if you want to check whether standard deviation, for example, of personal income is no less than a certain number, or for instance, you want to find out whether uh, standard deviations of two averages are the same. For instance, last 1 week ago, I mentioned that we have one assumption when we conduct the test, and this assumption is about equality of variances. And what if you want to know, or what if you want to find out whether these variances are the same using statistical tools or statistical tests? And today we are going to learn these simple tools well, and as usual, I have to explain some theoretical concepts, and we should do exercises in Stata with the given data set. Also, I'm not going to explain theoretical concepts, formulas in detail. Probably you did it in your probability theory course, but I would like to explain the intuition of each tool. Well, I think that's it about our plans for this meeting, and so let me start with theory. So what we have to learn today? Today we have to learn how to compare variances with a single number, or how to compare variances from two populations. Well, or how to compare standard deviations, which is the same. So first, when when we want to measure the variation of a variable, we usually use standard deviation because it's very convenient for us. First of all, it is measured in the same units as the mean, hence it is pretty easy to interpret it. Well, unfortunately, in statistics, we don't have a test that directly compares a standard deviation with a single number or two standard deviations. Well, instead we work with variances, and we compare variances with certain numbers. Well, and with numbers, or we compare variances if we have two populations. Well, and both tests, no, all of these tests rely on two distributions. First distribution is a chi-square distribution, and second distribution is F distribution or Fisher distribution. Well, and likewise, so likewise 2 weeks ago, let's start with the comparison of a single standard deviation with a single number. For example, you want to know whether a certain standard deviation is greater than certain number, or smaller than certain number, or equal this number. Well, and in this case, you have to conduct chi-square test. Well, how it works? No, first, this works as any test in statistic. And your first step for sure is to formulate research question. For example, is it true that is it true that standard deviation of income is, for example, greater than 0.5? Well, it is research question, so it has meaning, you are free in formulating it. Next, you have to reformulate, paraphrase your research question into statistical hypothesis. You have to create two statistical hypotheses. Well, and here we have one rule more. Well, all rules related to statistical hypotheses are the same. Highest equality must be in null hypothesis. So there are two hypotheses in our task. So null and alternative one. Well, but here you cannot use standard deviation letter to formulate hypothesis, because when we compare standard deviation, we calculate variances and we work with variances. Hence, all you need to formulate statistical hypothesis, you have to rely on variances first, and you have to transform numbers if you need to transform them. Like so, the square root of 0.5 is 0.25. Well, and as usual, we have to use two hypotheses. Well, again, remember, when we compare standard deviations with a single number, always rely on variances. In fact, you compare variances with standard deviations. And since this moment, I will mostly use word variance instead of standard deviation for simplicity. Well, and as any test in statistics, this test also has certain assumptions. And your job is to remember this assumption. So all of these assumptions, because we often ask students to list assumptions in our exam. Well, and our assumption is as follows. When the random, so first, your variable must follow a normal distribution. So random sample must be drawn from the normally distributed population variable. Next, and if we know that the random sample is from a normally distribution population, the distribution for the standardized sample variance is a chi-squared distribution. And this is important for our test, because if our variable doesn't follow normal distribution, well, our chi-squared test, our test can tell us wrong information. Well, but as any usual test in statistics, if your sample is sufficiently large, so this assumption isn't very important for us. If your sample is pretty large, well, you can work even with variables that doesn't follow normal distribution. And one assumption more, which isn't mentioned in this slide, note that we speak about continuous variables. So you cannot work with binary variable, you cannot work with other qualitative variable when you want to test variances. Here we work with interval or ratio data. Well, how this test works? This test works again as any usual test. Well, we have standard deviations. We can use the standard deviation to calculate variances. Well, now, no, in principle, so you know that because of sampling, we can obtain many different variances, right? Well, and if we compare variance with a single number, we should agree on a threshold. We should reach an agreement that, okay, for example, 10 is our threshold. Well, but if our variance is greater than 10, we should state that our variance, for example, is different from a certain number. I.e., we should reject null hypothesis. Again, this test works as any usual test in statistics. Well, imagine that you have a lot of variances because you have a lot of samples. Well, some variances can be greater than the population one, some variance can be smaller than the population one. You don't know population variance for sure. And what you have to do to test your variance, you have to find a threshold. So uh, you should reach an agreement that, okay, so our threshold is this number. If my variance is greater than this number, hence I have to reject null hypothesis. Otherwise, I cannot reject null hypothesis. For sure, it's not very convenient to calculate variances all the time and look for the right threshold. Well, and instead we transform our variances to chi-squared units. Likewise, we transform our averages to z units or t units or z statistics or test statistics. Here we transform variances to chi-squared statistics. To do this, we rely on this formula. N is the sample size, S is your sample variance, and sigma squared is the number you compare with. For example, if your variance is 0.5 and your number for comparison is 0.7, in numerator you should put 0.5 squared, and in denominator you should put 0.7 squared. Well, once you calculate chi-squared statistics, you should compare it with critical value if you have statistical table, or you should rely on p-value if you work with stata. Well, how to work with statistical table? First of all, you should define alpha. So you know alpha could be 0.05, 0.01, or 0.1. And next you have to find degrees of freedom. So in this task, we use n minus 1 degrees of freedom. Well, and how this table works. In your textbook, you have Appendix G, values of chi-squared for selected probabilities. And here you have a small example. Look, what this line is your threshold. Well, or it is your critical value. You know that threshold is our critical value. And if our estimated chi-squared is greater than this threshold, we should reject null hypothesis. Well, and here we have different alphas. So 0.005, 0.99. Here we have 0.005, 0.01, and so on, and so on. So you should start with this column and move to the left side. For example, if your test whether your variable, no, usually we start with the right column, and if you test, for example, or if your task tells that you should use alpha 0.05 or 5%, well, you should use this column, and here you have to find degrees of freedom. For example, no, in this example, so our alpha is 0.1, degrees of freedom is 5. Well, this is the number we look for. This is our critical value. Well, um, so it is a piece of theory. Now let's do a simple exercise. Now, everyone, please read this task. Read this task and press plus if you are ready to do this exercise. Read it and press plus if you are ready to do this exercise. Well, okay, good. I see that most of you read it. Well, so what we have here? Here we have that uh, standard deviation cannot exceed 3 minutes. Well, our sample size is 15 because to test whether the standard is being met, a random sample of 15 customers is selected. Well, we have mean service time 15 minutes with sample standard deviation equal to 4 minutes. Well, alpha is 0.05. Well, in this exercise, we have to compare sample standard deviation with its standard. We have to check whether, so you know that first, you work with sample. It's clear from the task to test whether the standard is being met, a random sample of 15 customers, random sample. We don't work with population, hence it is sample. Therefore, 15 therefore 4 minutes is a random number because if someone survey other persons, other customers, standard deviation can be different. Well, okay, we know that 4 is a random number, 15 also is a random number. Well, and 3 isn't random number because it's our standard. So hence S is 4, sigma is 3. Well, we have alpha, we have n 15. So it means that we have everything is required to calculate chi-squared statistics. But what we need to do first, we need to calculate variances. By the way, first we have to formulate hypothesis. Could you please try to formulate hypothesis by yourself? I know that you don't know how to write sigma or type sigma to denote that it is sigma. Try in the chat. In the chat, enter your version of research of statistical hypothesis. In the chat, please enter your versions of statistical hypothesis. Mhm. Okay, let's wait a little. Okay, not bad. Now, everyone, please remember, we always work with variances. Hence, sigma is means population standard deviation. Sigma squared means population variances. Hence, when we formulate statistical hypothesis, always use population variances, i.e. sigma squared. Once our standard is 3 and 3 is for standard deviation, we cannot use 3 as a benchmark number. Instead, we have to take we have to take power of 3. Well, hence we have to compare sigma squared with 9. And you are absolutely right. Well, null hypothesis is that sigma is no greater than 9, and alternative hypothesis sigma squared is greater than 9. Well, it is as usual, we have two hypotheses. As usual, equality must be here, and naught squared here, and 3 squared is here. Well, next we have to calculate chi-squared statistics. Well, no calculation of chi-squared statistics here is pretty simple. Sigma squared is 9, s squared is 4 squared, sigma squared is 9. Well, sample size n minus 1, 15 minus 1, 14. You don't have to calculate this with your calculator. Let me show. Well, this is our estimated chi-squared. And by the way, Stata also can calculate it. Well, next we have to find critical value of chi-squared statistics. Well, what we have to use to find critical values. First, we have to use our alpha, it is 0.05. And next, we have to use degrees of freedom. Our degrees of freedom is n minus 1, 14. Hence, how to find our alpha? 0.05 column, okay. And 14 is here, 23.6848. This is our critical value, 23.6848. Well, and what we have? Here we see that our estimated chi-squared is greater than critical value at this confidence level. Hence, we have to reject null hypothesis. All right, how to solve this exercise using Stata? Now, everyone, please open Stata. Everyone, open Stata. And let's do this exercise with Stata. Okay, I hope that you are ready. Well, so to solve such an exercise, and especially to check yourself when you work on your home exercises, I recommend you to use Stata calculator. And now let's learn how to use Stata calculator to compare variances. Well, we should go to statistics. In statistics, find summaries, tables, and tests. And in summaries, tables, and tests, find classical tests of hypotheses. Again, statistics, summaries, tables, and tests, classical tests of hypotheses, and here you should find variance comparison test calculator. Again, here you should use variance comparison test calculator. Please, everyone, open this tool. Variance comparison test calculator. Well, now you have such a table, and here we see name of the command. Instead, we can use command line to run this test, but for simplicity, let's use so this way. So as the test command. First, we have to define how many samples we have, one sample or two sample. So from the task, it's clear that we work with one sample only. Hence, you use this radio button as is. Next, we have to enter sample size. Our sample size, let me open, no, not this. Let me open this. So from the task, we see that random sample of 15 customers. Hence, sample size is 15. And here, by the way, it's even easier than in by pencil calculation. Our standard deviation. Here we have to enter sample standard deviation. Sample standard deviation is sample standard deviation equal 4. Okay, here I have to enter 4. Next, hypothesized standard deviation is 3. and confidence level alpha, our alpha is 0.05. Well, submit. And look what we have. Chi squared is exactly the same number, 24.89. Degrees of freedom, exactly the same, 3. And likewise, any test in state, we have null hypothesis. So it is reformulated using standard deviations. And we have 3 so alternative hypothesis. And we see, so our alternative hypothesis is this one from the task. And indeed, we see that at 0.05 level, we can reject null hypothesis. Well, and hence we can state that at 5% confidence level, while our standard deviation exceeds 3 minutes. Hence, standards aren't met. Well, this is the first exercise and first simple example. How can we use variance comparison test in practice? So, and one of the most frequent application is to check whether we meet some standards. Well, next. Another example, but what if you have to work with what if you have to compare standard deviation with a single number? You have to check whether your standard deviation is different or from some number or whether it is equal to some number. Now, everyone, please read this task and type plus if you are ready. Okay, all right. Here we don't have all necessary information. We need to solve this task because it is in the second slide. Well, but what we have to formulate here, we have two hypotheses. So was variance equal 36 or whether our variance isn't equal 36? Well, and how this test works. As usual, we have to calculate chi-squared statistics. But now, if we draw a picture, if we draw a chart with chi-squared distribution, we should find two critical values. First critical value is left one, second critical value is the right one. And hence we have to find two critical values from chi-squared table. Well, first and right critical value is very easy to find. Well, we have to divide alpha by 2. For example, our alpha is 0.05, hence our divided by 2 is 0.025. Well, and find this table, this value as usual, using 11 degrees of freedom is 21.92. But to find left side, or left threshold, you should rely on these borders. They are about left threshold, and 0.975 is for us, and threshold must be this one, 3.81. 3.81. Yeah. Well, and if we see that our estimated chi-squared isn't between a left threshold and right threshold, we should reject null hypothesis. Well, this part could be a little bit tricky for you because you need to find two thresholds and these thresholds are different. So in contrast with t-test or z-test, for example. And my recommendation for you doesn't matter whether you work with one side test or two side test. Please always draw such a picture and indicate where your threshold must be. On the left side, on the right side, to find what column to use. These columns or these columns. Again, my recommendation for students, once you conduct chi-square test, create the same picture. So take a pencil, create the same picture, and indicate where your threshold or thresholds must be. Preliminary for sure. You shouldn't find so exact numbers when you draw something. And if you draw such a picture, you can easily make a decision what column to use. For example, this one first, or this one first, or both. Do that, please. We won't do this exercise in Stata because we have a lot of things to consider. And next, for sure. So you know that it is possible to calculate confidence interval for the standard deviation, and by the way, we can also find confidence interval for population variances using such a formula. But what is different from confidence interval for the average, when we calculate confidence interval for the population average, we use a single number from t-tests table or z-test table, right? But here we have to use two chi-squared values, so left value and right value, or lower value or upper value, to find left and right border of the confidence interval. But for sure, estimating confidence interval is important, and you know that we can use it to also in hypothesis testing. An algorithm is pretty the same, likewise testing hypothesis about averages. But there is a much more interesting case. What if you have two variances? Both variances are calculated using different samples. And you need to compare these variances. For example, you need to compare variance. So you need to compare that risk of investment in Sberbank stocks and VTB stocks. What stocks are more risky? And you need to compare the standard deviation and highest variances. To do this, you should rely on also hypothesis testing, but you should rely on a little bit different procedure. First, if you want to compare two variances, you should ask yourself whether my samples are randomly selected, i.e. whether my sampling is good, whether variables are continuous. We cannot do this for binary variables, and whether my samples are independent. So independency here is important assumption. And for sure, so our variables must follow normal distribution, or otherwise your sample must be sufficiently large. And to compare two variances, again, you have to calculate statistics. You have to transform difference in averages to some values, and here we have to recalculate difference between two variances into f values or f statistics. And by the way, formula is pretty easy. You have to divide larger variance by smaller variance. That's it. Just divide two variances, and it will be your f statistics. And next, you should compare your f statistics with critical value, or you should rely on p values. How this works? Here we have one maybe a little bit complicated point. This point is about F distribution table and whether you have to work with so one F value or two F values. Well, first, my recommendation for you, what I mentioned that it's better to put larger variance to numerator and smaller variance to denominator. In this case, your F statistics will be greater than 1, and it should push the F value towards the upper tail of the F distribution. Well, and how to work with F distribution table? Well, it is chi-square distribution. Let's move. And in Appendix H, you can find F distribution table. And what you have to keep in mind, we have different tables for different alphas. But here our confidence level is 5%. If I scroll down, wait, yeah. I have, more tables, and for example, this is for 2.5%, and if I scroll down, it should be for 1%. Well, and if I'm not mistaken, we don't have so the same tables for other alphas. Well, and these tables are pretty large. Well, we have 300 rows, and this table, it have first 10 columns here. So it is another part of the same table. We have from 11 to 12 column, and it is the last part of the same table from 24 to 300 observations. Please remember that what this table are 3 elements of the same table. Well, and what you have to do, you have to find degrees of freedom for numerator and denominator. Well, and once you find right degrees of freedom, please find right column number, so row number, and use it and use this value so as a critical value. For example, if your degrees of freedom is 5, first one, second degrees of freedom is 10, this is your critical F statistics. Well, so this is about theory, how it works. No, for sure, we have here, it's easier to run the same test when you draw a picture. Well, we have two possible situations, one-tailed test, two-tailed test. So one-tailed test is clear, I hope, for everyone, because we have to compare, we have to find out whether our variance is greater than certain number or smaller than certain number. When we speak about alternative hypothesis, two-tailed test is about simple comparison when we need to check whether the variance is different from certain number, from another variance, or whether two variances are equal. Well, and here we should, so if we work with one-tailed test, we don't have to divide alpha by 2. If we work with two-tailed test, please don't forget to divide it by 2. Well, and decision rule is the same. If F statistic is greater than critical value, reject null hypothesis. That's it. What is difference between these two cases? The difference whether you have to divide alpha by 2. And note that it is pretty important because, for instance, this table works if you work with one-tailed test because you don't need to divide alpha by 2. For instance, your alpha is 5%. But this table cannot be used with alpha 0.05 if you work with two-tailed test. If you work with two-tailed tests, scroll down and use this table, 2.5. Well, so it is a common mistake among students, well, when students work with F distribution table. And for sure, this problem can be easily solved if you do sufficient number of home exercises, and for sure if you solve all of these tasks by pencil. Well, no, okay, this is theory, but what about examples? Please read this task. Let me read this task and type plus if you are ready. Okay, very good. First, we have two samples, right? Sample size 1 is 10, sample size 2 is 8. And also we have two standard deviations, 0.1, 0.45. Well, we have alpha 0.05. Well, in principle, we have everything we need to conduct a test. And what we should do first we have to formulate statistical hypothesis. To formulate statistical hypothesis, we can read the first sentence. The soft drink bottling company is considering two new filling machines and is interested in determining whether there is a difference in population standard deviation. Hence, we work with two-tailed tests because we check whether a difference exists between two standard deviations. And again, here, when we formulate statistical hypothesis, we cannot rely on standard deviations. So your textbook tells that we have to rely on variances and compare variances. Hence, our statistical hypothesis is 1 sigma squared equal second sigma squared, or this sigma squared are different. Well, you know that 0.5 is larger than 0.45, hence you have to put 0.5 in numerator and 0.45 in denominator. And it is your estimated F statistics. Well, degrees of freedom are estimated in the same way. It is n minus 1, as 10 minus 1, 8 minus 1. First degrees of freedom is 9, second degrees of freedom is 7. Well, now we can find critical value. We should find this threshold. We know that our F somewhere is here, so it's pretty small, somewhere here. How to find our table? Our numerator, so 0.5, its sample size is 10, hence degrees of freedom is 9, hence our column is this one, 9. Oh, but we cannot use this table because it is 5%. We should use 2.5% and the same column, this one, 9. Why 2.5%? Because it is two-tailed test. Okay, what about our rows? How many observations we have? We have 8 observations, but 8 minus... So do we have 8? Yeah, 8 observations. Well, n minus 1 is 7, hence... Okay, column number 9, 4.8 is our... Wait. Questions? Well, 8 and yeah, should be 4.8 in this task. So it's a typo. Well, and in principle, that's it. We see that anyway, F statistics is so smaller than critical value. Well, and we can reject. We cannot reject null hypothesis. Well, for sure, if we put alpha 10, well, yeah. So, and our critical value is for 10% confidence level. Well, now let's repeat this task using Stata. Again,
can I have a question about F critical? We need to see, we need to find the intersection in 9 and 7, and there we will have number. Do we have this F critical? Because if we will look in our table with 2.5%, we will have in this intersection, we will have 4.823, but not like in the...
Yeah, I mentioned that. So in my slide, critical value is for 10% confidence level. Not for
okay,
5%. This is for 5%. No, what we can say that we should reject null hypothesis at 10%, we should reject our hypothesis at 5%, and probably for 1% too, I think. Yeah, and no, definitely. So yeah, definitely for
okay, understood.
2%.
Thank you.
Well, all right, now let's do task and data. 2 samples, SD testing. Sample size is 10, sample size 2 is 8, standard deviation is 0.5 for 10 and 0.45 for 8. Alpha set the same and submit. So this is our output, 1.2346, exactly the same number. And yeah, looking at our p-values, we cannot reject null hypothesis. Type plus if you are ready with SD testy with statistical calculator. Very good. Well, so what conclusion can we make from this exercise? A managerial conclusion, whether there is a difference in populations, standard deviations. Well, our test cannot identify difference in population standard deviation, hence, well, yeah, bottles and fill the volumes were measured. So standard deviations in both samples, so we can say that the same, and there is no difference so in filled volumes in 2 samples. Well, in principle, that's it about comparison of variances using calculators and using different tools. What we can do else? We can use this task to make our t-test better. Well, no, let me mention that when our t-test, then when we assume that variances aren't equal in t-test, this is about t-test. Well, we should calculate degrees of freedom using such a formula. Well, and once we calculate degrees of freedom using such a formula, we can find easily rejection region and conduct the t-test itself. Well, no, here we can find example, but yeah. Now let's compare variances using database. Well, now everyone, 1 week ago we used dataset. 1 week ago we used dataset about income of entrepreneurs. Please open this dataset in Stata and type plus if you are ready. All right, now No, let's do everything step by step. So now we have data set, so we shouldn't use data calculator. And first, let's analyze a variable. Let me set larger font a little bit. Yeah. So let's analyze net income variable. You know this variable, it measures income after tax. Well, you are familiar with the average, and now let's speak about standard deviation. First, let's find confidence. You know how to find confidence interval for the mean, but what about confidence interval for the standard deviation? Well, to find confidence for standard deviation, you should go to statistics, summaries, tables and tests, classical test of hypothesis, and well, no, here. Summary and descriptive statistics, and here you have to use confidence interval. And also, by the way, you have standard deviation CI calculator if you want to check yourself. Confidence interval. Open this interface, please. Well, CI, you are familiar with this interface, but we used means. Now it's time to use standard deviations. And here you should enter variable name, netinc. Set confidence level, 95%. And click submit. Here use as usual normal, by default normal. Submit. Well, if you do this, Stata will calculate standard deviation and its confidence interval. Look, so sample standard deviation is this one, and its confidence interval is between these two numbers. By the way, it is pretty narrow because our sample is large. What if you want to calculate? So we can slightly change our code and calculate confidence interval for the standard deviation of entrepreneur's income. Well, so if I add if statement, if my self-variable, self-employed is 1, so this is standard deviation for my entrepreneurs. And look, so it's, by the way, also pretty narrow because probably I have a lot of cases, a lot of observations in my sample. Well, this is about confidence interval. And again, if we see that this confidence interval contain some numbers, well, we can use it as a very maybe a preliminary hypothesis testing. Next, let's compare two variances. Or let's compare variance with a single number. To compare first variance with a single number, go to classical test of hypothesis and find here variance comparison test. Again, to compare variances with something, or to compare two variances, please go to classical test of hypothesis and click variance comparison test. Well, no, let's do everything step by step. So one sample, two sample using groups, two sample using variables. First, let's compare variance with a single hypothetical number. For example, we want to check whether net income variance of net income is greater than, I don't know, say 1 million. Well, no, not 1 million. Let's put something realistic, 300,000, because it is standard deviation, hypothetical standard deviation. And click submit. Wait. This is my output. Well, note that this interface is pretty simple. You have to find variable you use to calculate standard deviation, hence variances. And here you have to enter a number you want to compare with. Click submit, that's it. And compare your output. And look, Stata here estimates sample average, sample standard error, sample standard deviation, while also it calculates its confidence interval for the average, for our average, and it calculates chi-squared statistics. It is pretty large. It is very, very large number, and definitely with such a large chi-squared statistics, so it doesn't make sense to look at your critical values. So definitely we should reject null hypothesis, and it is clear from p-values that, well, this number and our estimated standard deviations are different, and the standard deviation is smaller than this number if we look at these alternative hypothesis. For sure, a comparison of standard deviations or variances with a single number, it's not a usual task in our field, especially if you work with quality standards. If you want to check quality of products produced, you have to do this procedure a lot. But we often compare two variances. Well, and to compare two variances, we should slightly change this interface. We should use two sample using groups, and we can here enter variable name. It is our response variable name, for instance, net income, and group variable. It is self. Confidence level is as usual, and click submit. Please do this and look and reach this output. Now try to interpret this output. In the chart, enter please, write in the chat, should we reject null hypothesis or we shouldn't reject null hypothesis? And why? Because of p-value, because of f value, because of confidence interval, we have it here. So don't reject null hypothesis, and why? In the chart please. Okay, good. Konstantin, thank you. Let's wait a little. Wait, Arina, I will ask you a question. I will answer to your question. Wait. Okay, not bad. Let me explain. First, our null hypothesis tells that ratio of two variances must equal 1. What does it mean? Why 1? Because if my variances are the same, right? The ratio must be 1. Again, why null hypothesis ratio is 1? Because if we assume that variances are the same, the ratio must be 1. Well, and we know that both numbers are random, hence 1 is random too. Well, and different samples produce different ratios. Well, and we have to compare our random ratio with some threshold. Well, no, State doesn't publish critical value of F statistics. Instead, we have 3 interesting tools. First, we can look at, let's start with the simplest case. The simplest way to reach a decision is to look at p-values. If our p-value is smaller than any alpha we use, at maximum 0.1, we can state that we should reject null hypothesis at a given confidence level. We see that here alpha is 0, here alpha is 0. First, we should state that at least these variances or standard deviations are different, because this p-value is smaller than any alpha we use. Well, they are different at 0.01 level. Moreover, if we look at left alternative hypothesis and right alternative hypothesis, we see that p-value here is also 0. What does it mean? It means that this standard deviation is smaller than this standard deviation. It means that our test identifies or shows that this standard deviation is smaller than this standard deviation. Well, hence here again we should reject null hypothesis. And well, it is first way. Second way, to look at F statistics. 0.44 is pretty small F statistics. Well, if we open our table, let's open our table. Let's open the table with 1%, and you see that maximum number of degrees of freedom is 300. Here is 300 here. Well, we don't have 50,000 degrees of freedom. Well, hence let's use this number as a critical value from our table. It is maximum value. And by the way, real critical value cannot be very different from 1.3. And definitely 0.5 is smaller than 1.3. Hence, well, F statistics is smaller, but no, this part is a little bit tricky because we divide smaller standard variance by larger variance, and in this case everything is vice versa. It means that F value is, if it is smaller than critical value, we should reject null hypothesis. Well, it is if we use, for example, this option. No, it doesn't work here. No, just remember here, maybe for you, so if you understand how this test works, you will see that sometimes in this case we can reject null hypothesis when F value is smaller than critical value. Well, if we divide smaller variance to larger variance. But your textbook offers a simpler procedure to divide larger by smaller. Well, and the last case is to look at confidence intervals to check whether they are different or whether they overlap each other. No, we see that, well, if we look at this confidence interval, we see that 0 isn't in this confidence interval, hence we should reject null hypothesis. But when we compare variances, my recommendation for you, don't use confidence interval approach. And if you work with data, don't use this approach, because this approach requires extra reading and extra hours for learning this test. Please rely on p-values only. This approach will be consistent with your textbook. So as you see this, our textbook simplifies some topics within so paragraphs we study. Well, once we see that variances are different, it is a clear evidence that we should use when we work with t-test. We should use unequal option when we work with t-test. So because we identify that variances are different. Well, and without unequal option, so no, our t-statistics is different. Results could be different, as you know. Well, in principle, that's it about about comparison of variances. What will we do next? Next we will next week we will I suppose, yeah, we should finish so with parametric statistics. I guess we should finish with the analysis of continuous variables. Yeah, well, and in December we should learn how to work with qualitative variables, different proportions, different indices of happiness, satisfaction with labor conditions, and so on. And our final topic with continuous variables, I have two final topics, is ANOVA and correlation coefficients. We won't discuss ANOVA in detail. We will discuss ANOVA in brief, well, because our hours are limited. And also in brief, we will discuss correlations. Well, and I think that we will do this next week. No, at least ANOVA we will do, so we should do next week, maybe correlations in a week. Well, I think that's it for this week. Do you have any questions?
Yes, I have a question. Yeah. When we do variance comparison test, and there we can find our confidence interval, and it is confidence interval for our means or for our standard deviations.
Let me check. Wait. Wait. Oh, no. It's wait, 3, 2, 1. No, sorry, yes, you cannot use here confidence interval estimation, at least in Stata approach. Yeah, because it is for means. Yeah, thank you.
Thank you.
It's not R. Well, some final remarks, please. Again, when you compare two variances, don't forget to divide larger variance by smaller one. It can simplify your task. And do your exercises by pencil, and please draw distributions, so chi-squared or f distribution. It could also help you to find to understand how all of this stuff works. That's it. If chi-squared is smaller than critical values, then we don't reject null hypothesis, right? No, but Valeria, so my comment is about one-tailed test. If you speak about two-tailed test, your chi-squared value must be between two critical values. That's a tricky point, and this is the reason why I told that you should draw pictures. that's it. Okay, well, thank you very much. So I think that our meeting is over. So see you next week.
Thank you. Goodbye.
Goodbye. Thank you.
Goodbye. Thank you.
Sorry, can I ask you a question?
Let me stop recording.